everyone, I'm Swati and welcome back to my series on mechanics. We are learning vectors. आज का वीडियो थोड़ा इंटरेस्टिंग है because in this video we are going to learn some concept on resolution, how to add, subtract the vectors. So let's begin with that. Okay, so in the last video of vector, we have learned about the resolution and we have done some numericals on that. It is like a same vector has a component on x-axis, y-axis and z-axis, and the combined effect give you the net, the resultant, that vector. So in the resolution of vector, what we have learned, just a recap of that is, suppose in 2D plane, that is x and y, there is a vector A, and you can have a projection on x-axis, that is make a perpendicular from it, stand on x and y-axis, and this is your ax and that would be your ay. Okay, so you can resolve this if this A makes some angle theta. So with whatever axis it makes an angle theta, that resolves to be cos theta and the other become a sin theta. So that A vector can be written as ax I cap plus ay j cap. Now, or it can be written as a cos theta I cap plus a sin theta j cap, where your ax जो है become a cos theta, ay is a sin theta. Very easy. Now if they are in 3D, it's in 2D, and if we talked about 3D, you just need one more factor here, but then it will resolve in only cosine terms. Okay, that we will learn later. But if we need to add addition of these vector, so the concept is again very easy. If the vector is in its component form, let's say you have two vectors here. One vector is this, let's say one vector is this A vector. So it has two components, ax here, ay here. Okay, and you have another vector B here. It has one component here which is bx, another component here which is by. Okay, now you can see that bx and ax are along same, and you know to the resultant of the vectors. Okay, we have already learned that resultant of vector in our previous videos. So if two vectors are in same direction, you can simply add them. If they are at opposite direction, you can simply subtract that, and if they are making some angle, then you can use a square plus b square plus 2ab cos theta. So now ax and bx are in same direction, ay and by are same direction. So if you need to add a vector plus b vector, all you need to do is to add their components. That means ax plus bx I cap plus ay plus by, and they are also commutative. You can do a plus b or b plus a, it's same thing. So like that. And if they are in 3D, or only z factor also come there, like az plus bz j cap. Okay, so in 3D it can be simply as a vector plus b vector can be written as ax plus bx I cap plus ay plus by j cap plus az plus bz k cap. Okay, and if you have three vectors a plus b plus c, then you have to add ax plus bx plus cx, ay plus by plus cy. It's as simple as that. Okay, so let's say you have this a vector which is 3i cap minus 7k cap, and you have this b vector which is like 2i cap plus j cap. Now if you have to add this a vector plus b vector, then you have to add these I component, j component, k component. You have I here, so you can do 3 plus 2 5 I cap. Here is k, but there is no k. So but here is j, there is no j, so simply j is j cap only. 0 plus 1, and it is minus 7. Here is 0, there is minus 7 k cap only. So for subtraction itself, the minus sign come there, but as a whole it remains same. Okay. Okay, we can consider one more question. Let's say you have two vectors. Let's say a vector 2b, 1 I cap plus 2j cap plus 3k cap, and a b vector is simply I cap minus j cap. Now they are asking that what vector should be added in these two vector so that the resulted is a unit vector along j cap. What vector, sorry, what vector should be added so that the resultant become so that the resultant become a unit vector along j cap. Okay, so it's basically what you will do, your a vector plus b vector and some c vector which is unknown should be equals to your j cap. It's a unit vector which is along y axis, not j cap, along y axis, that is j cap. So what you will do, your a vector is simply what, 1 I cap plus 2j cap plus 3k cap, plus b vector is I cap minus j cap, plus c vector gives you j cap. Now this c vector will become j cap, and take all these terms there. 1 I cap plus 1 I cap plus 2 I cap gives you minus 2 I cap, plus 2 minus j is plus j gives you minus j, plus 3k give you minus 3k, and you can cancel minus and plus. So this c vector would be what, minus 2 I cap plus 3k cap, and you will get a unit vector. That means whose magnitude is 1 and direction is along y axis. We can take one more example here. Let's say you have this condition and a box is here. Okay. Now three forces are applying there. One is there, one is there, and one is there. Let's say this is in 30 degree and of 10 Newton. This is 4 Newton and this is the force F, and this makes an angle of 60 degree here. So we are asking that what should be the force, what should be the magnitude of this force so that this object remain in equilibrium. Object remain in equilibrium. Okay. So what you can do, you can resolve it. Now this 10 I cap gives you here 10 in the direction of theta gives you cos 30 degree. This gives you 10 sine 30 degree where there is no angle. This is only along x-axis, you don't have to resolve it. This force can be resolved here. C, it become F sine 60 degree. Let's take the thing as this, that you don't have the angle here. You just have to calculate F. You don't need to resolve that. The thing is this force, and this force along with this force should be equal. These components, y components and x components should be equal so that this object at origin remains at equilibrium. So what I will do, it's like the first force